Hey guys, so welcome back to your next class of Catalyst Concepts. In the previous class, we looked at what exactly is positive work and what is negative work, right? So today we are going to look at examples of what questions based on negative work can look like. Okay, the sums that we tried out before were based completely on positive work. However, these are not those; these are based on negative work. Okay, as we read the sum, we can be able to figure out why exactly it is negative or positive. Okay, so let me read through the first question over here. It says a box is pushed through a distance of 5 meters on a floor. Okay, so there's a floor and a box, and it's pushed for 5 meters of distance. Okay, the displacement is 5 meters. It's offering 50 Newton of resistance. Okay, so that resistance is offered by the floor. Okay, now what is the meaning of resistance? Resistance means to try to stop something from moving. Okay, that is the meaning of resistance. Okay, so if the box is moving like this, the floor resists in the opposite direction, which is nothing but your friction, right? So this is the force of friction. This is basically nothing but your frictional force. Now the question is, how much work is done by the resisting force? Okay, since the works resisting force work is to stop the object, it means we are trying to reduce the energy of the object or the reduce the speed and by reducing the energy. That basically means we are talking about negative work. Okay, anything that resists is a negative work. So we need to calculate negative work over here. Now, how exactly can we calculate negative work? It's as simple as following the name, right? We already know that if we want to find out how much is the work done, we have a formula for that, right? I'm just going to write it at the bottom over here. We know work equals to force into displacement, right? This is what we wrote for positive work. We can use pretty much the same thing for negative work. Basically saying work equals to force into displacement. Same. But the only difference over here being, since it is negative work, we need to use a negative symbol. Okay, so answer you just multiply it by minus. That is all. Okay, you're going to be taking negative F into S. That will give you your negative work. As simple as that. Okay. So using this formula, we can solve these two sums. Let's go one by one. All right. So for the first one, let's see what is given to us. Okay. So they have given our displacement, which is nothing but 5 meters. All right. There's a box who's being pushed through a distance of 5 meters. Right. Okay, and the resisting force, right? Since the movement is like this, I'll say force is in the opposite direction. The resisting force is nothing but 50 Newton. If the S is in this direction, force is in this direction, right? We are not talking about the force that pushes the body. We're talking about the force that stops the body only. All right. Now, they have given us the resisting force value, which is nothing but 50 Newton. All right. So all you need to do is substitute these values in your formula and then you will get the answer. Okay, so I'll say W equals to minus F into S, right, which is nothing but minus 50 into 5. Just make sure your units are correct. Newton meter. Newton meter is yeah, acceptable, right? So 50 into 5. How much is it? 250, right? So minus 250. So the amount of work done is minus 250, the unit being J or joules. Okay, so we can say therefore the resisting force. Okay, since they asked specifically for resisting force by that name, they didn't say friction. So I'm using the same name, resisting force. That's how you conclude your sum. Therefore, the resisting force does, not offers, does minus 250 joules of work. Okay, I'm going to write it like that and we'll finish the sum. Okay. So let's move to the second question like this. Okay, I'm going to read the question out to you if it's not clear. A ball of mass 2 kilograms is thrown up and reaches a height of 6 meters. Okay, so we have a ball of 2 kilo, quite a heavy ball. We throw it up and it reaches 6 meters of height. It reaches up till 6 meters. Okay, some shot put thrower, world class. Now, what they are asking us to do is calculate the work done by the gravity. Okay, calculate the work done by gravity. All right, so let's look at this case. Someone has thrown a ball up 6 meters. Okay, so this displacement is in this direction S. Okay, now if this is the displacement, means we are putting force in that direction. That is for us to throw. But they are asking you calculate work done by gravity. Okay. Now, when a ball is going up, gravity's work is only to slow the ball down. Like we discussed, that is the reason the ball slows down and stops. Okay. So what is the total work done by the gravity on the ball from here to here till the point it stopped? Okay. As we know, force of gravity acts in downwards direction, right? This is nothing but gravitational force. Okay. This is nothing but friction force. I just put it like that. Gravitational force is down. So if you see, displacement and force are in opposite directions, which means again negative work for us, right? So this is what we are going to be trying to calculate, work done by the gravity. All right, so let's first write with the what is given to us. Okay, they gave us the mass of the ball, which is nothing but 2 kilogram. Okay, they gave us they asked you to take G value as 10. Okay, sometimes they'll say 9.8, sometimes they'll say 10. Just use the value they give you in the sum. That will depend on who's giving you the sum, and the calculation will be easier with 10. Okay, now what else is given to us is the displacement, which is nothing but the height in this case, right? Which is nothing but 6 meters. Okay, now we know W equals to minus F into S for this case, but over here we do not have an F value, right? We still don't have the force, but we already learned how to calculate force, which is nothing but mass into acceleration. In this case, acceleration due to gravity. Okay, so I will first calculate the F value, that is 2 into 10. Okay, so force is nothing but 2 tens are 20 newtons. All right, kilogram and meter per second square, if you multiply we get Newton. All right, now we have our F value, we have our S value. What is remaining is to find out our W value. work equals to minus force into displacement, right? Nothing but minus 20 into displacement, which is 6, right? So 2 6s are 12, so it is 120 minus 120. The work done is minus 120, the units being J, joules. Okay, so the gravity does 120 joules of work in the negative direction. All right. So if you have to write the concluding statement, you'll say therefore work done by gravity. Okay, you can simply pull up the last statement over here. Okay, work done by gravity is 120 J or joules, or you can write as joules if you want, or J, either way is fine. Okay. Or minus 120 joules, sorry, my bad. Okay, minus 120 joules. You can use the same ending statement here also. He's asking how much work done by resisting force, or work done by resisting force is minus 250 joules. You can write like that. Okay, so this is how you can solve for negative work sums. Okay, basically the same. You just need to make sure you're reading the question carefully. Okay, read whose work they're asking to ask. Work done by the person or by the resisting force. Okay, based on that you will know which formula to use. All right, so that's it for today. Thank you so much, and I will see you again in your next class. If you have any questions, you can drop them in the comments below. So for now I shall leave. So thank you very much. Bye bye.